Hi, everyone. Hello, welcome. We are going to wait just a minute or two more to let more people in, obviously. But hi, welcome everybody who's joined straight away. Lovely. I like an early bird. Here and keen. I like it because we have a really good session for you today. So yes, if we just wait a couple minutes and then we can get going. Hello, if you are joining us on LinkedIn, I see you guys. Hi. Hello, if you're joining us on Twitter, or X, I should say X, shouldn't I? But it's Twitter. It's Twitter. We know it's Twitter, but it's X. And hi, if you are on YouTube as well. Hi. If you have any questions, please do answer them, no matter what platform you're on, or if you're on StreamYard and there's a box this corner over here. Please ask your questions and we will answer them at the very end, and I can see them all come, so it's all good. So, are we ready to begin? I think so. Hi everyone, my name is Georgie Ryan Casling. I am the head of partnerships and the marketing team for Witekio. If you haven't been to a webinar before, hi Jordan from Colombia. Hi, nice to see you. If you haven't been here before, then hi, Georgie. And today I'm really excited about this webinar because it is all about high-performing GUI development on the Infineon Traveo T2G MCUs, which is hard to say if you say it 3 times in a row. This webinar is brought to you by Witekio in partnership with Infineon and QT, obviously the Qt group. And I'm going to let our lovely speakers introduce themselves. I'm going to go through the agenda and some housekeeping rules before we begin. So first of all, what are we going to talk about? Well, obviously you signed up, so you know lots of things, from Infineon talking about the hardware, how to select the hardware for GUI development and their product range. Qt talking about all the amazing tools they have to make sure that that development is as smooth, as easy as possible, and that it does actually work the way you want it. And then Witekio and the lovely Remy to talk all about the actual technicals of how you do that. Like, how does it happen? So I will let the speakers go through it in more detail. But very quickly, if you don't know who Witekio are, hello, we are an embedded and IoT software services company, and we do everything from chip to cloud. So your low levels to your middleware, your application development, to using tools such as obviously Qt, who we are a partner of, to everything from cloud connectivity and beyond. We have 5 offices. We've done this for 21 years. And if you don't know us, please do come and say hi on our website. We do everything from public vending machines to home appliances, medical devices, obviously, whatever your industry, we can help. And as I said, our skill set is vast, from chip to cloud. And we have partnerships with some of the biggest names in tech, including Qt and, of course, Infineon, which is why we're all here today to talk about how we work together to solve your needs. So that's it. I'm over. You won't hear from me until the very end, when I will be answering your questions with the guys, and I'm going to hand over to the speakers to introduce themselves. Remy, if you'd like to go first, and then Johan, and then we move down. So yes.
Yes. Hello, everyone. I'm Rémi Roux, the application team lead in Witekio Lyon. What my team and I do is bringing to life the device from our partners. It's a bit broad. So we have a specialty in C++, building application with the Qt framework, and also on MPUs, usually, and Linux embedded system. So today I'll speak about how we can transition from this world to the new developing world, not really, but really developing these past years to the MCU, and more particularly the one done by Infineon, using once again the Qt framework.
Hello, everyone. So my name is Johan Lopez. I'm a product manager at Qt Group, specifically responsible for everything MCU related, so microcontrollers. And that for us means this product called Qt for MCUs. So today I will give you a brief introduction about what Qt for MCU is and how what it can bring to you when used together with the Infineon Traveo 2.
Hello everyone. Welcome to this webinar. As Georgie said, my name is Sankalp Agarwal. I am Product Marketing Manager for the Automotive Microcontrollers. And in this particular webinar, I will focus on Traveo second generation of microcontrollers, specifically the cluster and graphic MCUs, and how these MCUs can be used in the applications beyond automotive, for example, medical applications, which our colleagues from Witekio will demonstrate in the later session. So, as I mentioned, in this webinar, we will focus on Traveo cluster MCUs beyond the automotive applications. And going forward, let me give you a brief introduction about Infineon. So basically, Infineon is the #1 automotive semiconductor supplier in the market. From the last year, we have already gained the market position in the automotive semiconductors. The total market grew by 16.5%, and we have already the #1 position in the MCUs, leaving behind our competitors, Renesas and others far behind. So what is the reason why Infineon is the #1 semiconductor supplier or #1 automotive MCU supplier? It's obviously because of the Oryx, which is the first choice of tri-core microcontrollers for the OEMs, as well as the Cortex-M ARM-based Traveo and AutoPSOC microcontrollers. So as I already mentioned about the Oryx family, it's based on the tri-core architecture. It's ASIL-B compliant as per the automotive standards. It's also ISO 21634 compliant as per the industrial standards. And then we have the Traveo as well as the AutoPSOC family, which are based on ARM Cortex-M. So what does it mean? It means low power consumption, high performance, and optimized performance. Till now, obviously, as you can see, Infineon has shipped more than 1 billion microcontrollers, which are somehow on the road, not only in the not only in the automotive field, but as well as in fields which are close to automotive, for example, commercial agriculture vehicles, in the forklifts, in the medical industry, as well as in the telecommunication. Looking at the technology roadmap, the automotive piece of microcontrollers, they are based on 130 nanometer technology. Why automotive piece of microcontrollers are special? Because they have the integrated analog front end. For example, the Wheatstone bridge, as well as the ADCs, the BMS portfolio, which we will be launching later in the coming years. Then moving on to the Traveo second generation family, it's based on 40 nanometer technology, and of course, the audience who knows the Oryx family, the TC3 and TC4. The TC4, it's based on 28 nanometer technology, and the fab which we are launching recently, it's in Dresden, based in Germany. And of course, for the next generation, yeah, there is a surprise. So I already mentioned about the three families of the microcontrollers. Normally we call them the automotive microcontrollers, but the focus over here, it's beyond automotive. So let me just briefly introduce the Oryx family. So as I already mentioned, the Oryx family, it's based on the tri-core architecture from the automotive standards, ASIL-B compliant. Uh, the flash, it's up to 21 megabytes, but it comes in different memory density and the pin configurations. It has a parallel processing unit, which is very suitable for the artificial intelligence. Then there is the cybersecurity runtime module for the hardware security purpose. And of course, the cryptographic engines are there, and the temperature range is as per the automotive standards. Then we have Oryx TC3 family, which focus on the applications which require less performance than TC4 family. For example, chassis and safety, powertrain applications. Similar to TC4 family, TC3 family is also ASIL-B compliant. It supports up to 16 megabytes of flash, has the hardware security module, which is based on Cortex-M, and similar to TC4 family, it supports the same temperature grade for the automotive microcontroller business. Now coming to the Traveo second generation family, this family supports automotive body applications, for example, driver information, the high-speed peripherals are there for the connectivity purpose. And then there is second part of Traveo second generation family for the cluster graphics, HUD, which is the heads-up displays, and the HMI applications. Traveo second generation family, it's as per the automotive standards, it's ASIL-B compliant. It supports 6 different low power modes, which we will see in the next slides. This family supports up to 16 megabytes of flash. It has the hardware security module, which is based on Cortex-M0+. The Traveo cluster family has 2.5D graphics engine, and of course, in terms of the temperature grade, it supports up to 125 degrees Celsius. For the low performance applications, we have Auto PSOC family, which is based on Cortex-M0+ and Cortex-M23. In the future, we will be launching the family which is based on Cortex-M23, and it will be ASIL-D compliant, similar to the Traveo family. As it is based on the Cortex-M architecture, it supports different low power modes. And as I mentioned, it is very high, very rich in features related to the analog front ends. Other than that, it has the CapSense integrated, which is the 5th generation of CapSense with very good signal to noise ratio. Different analog converters, the MaxSense, and as well as the Wheatstone architecture to support different functionalities, for example, air mass gas flow. So the focus today, it's the Traveo second generation. So looking in some details of the applications where this family can be used. So this family can be used in the central gateway because of the high speed connectivity peripherals. In the body control modules, we have already talked about the heads-up display, seat control units, different cluster applications, digital mirrors, and so on. To provide a brief overview of the whole Traveo family, this family can be divided in two parts. So basically the Traveo family for the automotive or industrial body related applications. And then we have the Traveo graphics family for the automotive, industrial, medical, and also in the aeronautics applications. So looking first in the Traveo body family, so we have Traveo body entry, which is based on Cortex-M4. This family supports up to 4 megabytes of flash, 512 kilobytes of RAM, and of course, different pin configurations. And just to let you know, the whole portfolio of Traveo family, it's scalable. So basically, there is pin-to-pin compatibility. Now looking at the Traveo Body High family, this family supports up to quad-core Cortex M7, coming in different flash and RAM configurations. And obviously, the external MMC is supported. Looking at the Traveo graphics family, we have over here the highest performing device, which is dual core Cortex M7, running at 350 megahertz. It has 2.5D graphics engine. There is video input output support is provided. Heads up display is also supported with the new upcoming device, and the JPEG decoder and hyperbus are also supported. So to summarize, basically the features of Traveo family. So the whole family is based on ARM Cortex M, which means it supports low power. As I mentioned already, we will see different low power modes in the upcoming slides. The family supports CAN-FT and up to 1 gigabyte of Ethernet interface. There is a dedicated hardware security module, which is based on Cortex M0 Plus. And the best part about hardware security module is that if the security from the cyber security purpose, it's not required, this can be served as a separate core, which means if the device is dual core Cortex M7 plus HSM, which is Cortex M0 plus, there are 3 microcontroller cores within the same device. The whole family is Evita full, and also from the cyber security purpose, the whole family is ISO 21434 ready. Traveo family supports true firmware over the air update, which is first in the industry, which means when there is an update of the firmware, there is dual bank support. So in one bank, the firmware can be downloaded, and it does not really interrupt the normal functionality of the application. Yeah. So basically, when there is a boot time, then the firmware updates. And if there is an error in the firmware, it can be rerounded. I already mentioned about the ASIL-B compliance, and of course, all the softwares and the drivers are available. So what is the new addition in the Traveo graphics family? The new addition over here, it's the Traveo second generation graphics augmented reality for the heads-up displays. This device will be again based on dual core Cortex M7 running up to 320 megahertz. I already mentioned about the ASIL-B compliance as per the automotive standards. The best part is the video RAM, which is 4 megabytes. And why video RAM is really interesting, because it reduces the time lag uh, because of the on-the-fly rendering, which is the best part of the Traveo cluster family. There are 2 video input channels, 2 video output channels, Hyperbus, HSM, and yeah. So now you must be wondering why Traveo cluster is better than a graphics system on chip. Yeah? So basically, for a graphics SoC, you need external power supply PMIC, you need vehicle interface processor, external boot flash, external RAM, which at the end costs some money. On the other hand, Traveo cluster family, the microcontroller, it only needs external regulator and supply. And of course, the PCB is nominal, which is 4-layer PCB. So at least Traveo cluster microcontroller family saves about $7 in the overall build of material, so the BOM cost. Looking at some of the applications where our customers are using Traveo cluster and graphics microcontrollers. So as you can see in the driver monitoring system, in the cockpit system, here in the front light applications, and of course the heads-up display. So to summarize the key features of Traveo family, its low power mode, it's the best one. It supports 2.7 volt to 5.5 volt input supply. The performance is really good because it's based on Cortex M4, single Cortex M4 up to quad core Cortex M7. For Traveo cluster family, it's only based on dual core Cortex M7, which means up to 1500 Drystone score. The whole family, it's scalable, which means it's pin-to-pin compatible, coming in different memory density and the packages. From automotive standard, this family is ASIL-B compliant. True firmware over the air update, true firmware over the air feature we have already discussed. It has high-speed connectivity interfaces, for example, 8 megabyte uh, of frames transfer, which is supported by CAN FT, and of course, 1 gigabyte Ethernet interface. From the security perspective, the whole family is Evita full. Hardware security module is there based on Cortex M0 Plus. And comparing to the Traveo first generation, Traveo second generation of microcontrollers provides 3 times of performance. So we have already seen different aspects, and just to summarize over here again, so the hardware safety manual is available for Traveo second generation of microcontrollers. The FMEDA is also available, and the software drivers and the MCAL drivers are also as per the ASPICE compliance. So why the graphics subsystem of the Traveo cluster or the graphics microcontrollers? It's important because they offer 2.5D graphics engine for the on-the-fly rendering. It supports high resolution of displays because of the internal VRAM, and there is a minimum time lag. The safety features are as per the ASIL B compliance from the automotive standards. It supports the JPEG decoder to support the JPEG motions, and with the external DDR interface, the external memory can also be connected. So the key takeaways of Traveo family, depending on the choice of device, it can be based on single core Cortex M4, M7, or up to quad core Cortex M7. Low power consumption mode, which is we discussed, it supports 6 different low power modes. Deep sleep mode, it's very important because the power consumption, it's only 35 microamps. And why it is important? It's because the CPU, the flash, and the high-speed peripherals, they remain in retention. So basically, a device can perform as per the need of the application. Supports wide range of voltage starting from 2.7 volt to 5.5 volt. True photo feature because of dual bank flash, and it makes the hardware really safe. Pin-to-pin compatibility because of the scalable feature of the whole Traveo family. And the hardware security module, again based on Cortex M0 Plus, which is like another second core for the on the device. These are the multiple kits that are offered by us for different applications. So for example, if there are developers who do not need high cost kits, they can simply start the development or the student projects using the Traveo body low cost kits or the Traveo cluster light kits. The software and the HMI tools are already available. With that, I will come to the long-term availability. So I will only focus over here on the Traveo second generation, which is available right now, and it will remain available until 2042. And after 2042, we will decide if product discontinuation is required or not. All right, then I hand it over to Georgie once again.
Thank you so much. I'm going to hand it over straight away to Johan. So away you go.
Thank you, Georgie. Thank you, Sankal. So before I go on my topic, also very brief introduction about who the Qt Group is. I'm assuming you might not be all familiar. So Qt Group is the company behind the Qt product and technologies, basically. Even though the Qt project and the libraries around it have been around for, well, more than 25 years, I think now. And there are millions of users today using it. We have also many customers. You might know that as an open source project, but basically there's a company also behind offering commercial product and add-ons and tools around the Qt technologies. So today the Qt Group has more than 800 employees, so it's been growing continuously over the last years, and you see some numbers here. If you move on to the next slide, Georgie. Thank you. So, and Qt really is not just about the graphics. It's really what most people know, why they know it. It's the graphics libraries and the graphics tools. But really today we're trying to offer a complete development workflow and the tools that support it. And that's really the agile workflow. So enabling different teams and different people to work together at different steps of the development so that the cycle gets shorter and shorter. So we have different tools, not just for application creation, but also, for example, for quality or for management, like, for example, the not too long ago released Qt Insight for helping our customers track usage of their devices. Then now more directly on the topic of today, so Qt on the Traveo 2. Here really, if I would explain in a nutshell why Qt on Traveo 2 is basically that it's a solution that lets you create graphical devices on a level that would be, I would classify as high-end, but with much more efficient or cost-efficient hardware solution. So Sankalp already explained that with the Traveo, compared to competing solution, the costs can be lower. But when comes Qt into the picture, it's about enabling you to create the same type of user interfaces that you could create, say, on much more expensive SoCs or desktop on mobile, and bringing that to these more cost-efficient solution. And again, Qt supports many different hardware. Again, literally almost anything from very powerful PCs to powerful smartphones to very low-end SoC or high-end SoCs to MCUs. So we're able really to compare what can be expected from these different platforms. And here again, what we can say is that with this platform, it's possible to achieve, let's say, MPU-like performance with similar kind of requirements and tools. So in the end, you get more for less. With the Qt tools, you benefit from the same boost of productivity. So we often hear from our customers that compared to other technologies, they are able to shorten their development time by up to 50%. And the other thing, which I will develop a bit more in a coming slide, is that we've seen at least that at similar, let's say, price point, this solution also offers the best performance in terms of frame rate or memory footprint. So now if we dig deeper a bit this first point, so why do you get more for less? I'm not going to explain too much on the cost. I think Sankalp already explained that. Basically, you just have a lower BOM cost because of fewer components needed, and the chip itself also is often cheaper. But then again, bringing Qt into the picture is, as I said, is really about bringing all the power that Qt is known in terms of advanced user experience and enable that fully on these microcontrollers without or with as little compromise as possible. And this is why I think Remy will show also later, bringing such kind of more advanced maybe graphic application and running this on a Traveo. And I can see here basically maybe two reasons for you possibly to consider this. Is first, well, you might already have some MCU-based devices with maybe somewhat limited user experience and also maybe on low resolution. And you're considering creating a new product that has higher graphics requirements, maybe especially higher resolution. And maybe you're considering switching to an SoC for that. So here, this might be a good alternative. Keeping your, let's say, ways of working on an MCU using Qt to help a bit bridge the gap in terms of advanced graphics. Or the other case could be if you're already creating, let's say, high resolution, feature-rich user interfaces on SoCs that have typically OpenGL and much more RAM and therefore more costly as well. And this could be a solution to preserve, let's say, or keep the same kind of experience and capabilities, but using a more cost-efficient solution. So no, let's say, really trade-off on the performance, but just lower costs. Now, what does it mean, really, Qt for Traveo? So it's really not exactly the same kind of Qt you would maybe expect if you've already used Qt. It's a separate product that we call Qt for MCUs that really brings some of the core technologies and tools to microcontrollers. And it was the last missing bit in terms of platform support, in addition to desktop, mobile, web, or MPU. And what we make available on MCUs is, first of all, a rendering engine that we call QtQuick Ultralight. Maybe you know already QtQuick and QML. So it's a variant of it, which is directly compatible with the normal QtQuick and the normal QML. But it's a subset. So it's smaller, it's faster, it's smaller in footprint. And it has a subset of the APIs you would find in BigQt, but available on MCUs. And we also bring all of our tools, the same ones you would use for other platforms, so Qt Creator, Qt Design Studio, so that you can create these applications for MCUs. Now, why can Qt help you with productivity and how can it boost? So very shortly, it's, I think, all about parallelization. And our tools aiming at enabling you parallelize more work across the development. A typical embedded development project will have always more or less the same phase, from design to prototyping to development to validation. These are often done in a sequence, reusing resources between different steps and therefore wasting time. So with Qt tools, we aim to bridge again all these different phases, different people to work more closely together right from the start. For example, not waiting to have a full design before prototyping, but for example, starting prototyping right away, just having some initial design mockups, for example, and validating that everything actually works on the hardware. And then taking this into development and continuing without kind of starting from scratch from the design elements. Then I mentioned earlier that another, let's say, key feature of the solution is the performance. What we wanted to really verify this. So I said earlier, we support various MPU, MCUs, and so on. And here we wanted to compare how does Qt fares on different chips on the similar, I would say, same positioning on the market. And the results were really, I would say, quite impressive. You see the numbers now on the screen. So the Traveo is the kind of yellowish lime color in the graph. It's better at performance, so it can render at higher frame rates on the same resolution compared to others. But also, maybe more importantly, the minimum frame rate is also much higher, which is typically what you would notice when there's a drop at some point, because something is heavier, and this really affects the perception of the user experience. And then also quite impressively is the memory footprint that you see is up to 5 times less for RAM usage, for example, thanks to some on-the-fly rendering mode on the Traveo, which requires fewer, less memory for frame buffering. And then, of course, boot time also has been observed to be very fast here. So really a very competitive solution when it comes to performance compared to other alternatives, hardware alternatives. Here, well, this is basically the same thing, but I wanted to share some of the numbers to give you an idea of what it takes in terms of memory, especially to create this kind of application. And we see a screenshot on the left here. Maybe there's a video. I'm not sure if it works, Georgie. If it doesn't, it's fine. You at least get an idea here on the picture. It's I would say a fairly typical instrument cluster. There's more than what you see here. There are different screens and so on. But you can with 2.5D, with different kinds of animation transitions and so on, and you can see that creating such application, which could, by the way, really be done on an SoC as well. I've seen many of these kind of applications on SoCs, but here requires much less memory, only, well, a bit less than 800 kilobytes of RAM to run this, and only 2 megabytes of flash. So it's not only better than some other MCU-based solution, but also a lot better than something which would look exactly the same, but on a more like powerful SoCs. Now, what do you get with Qt on the Traveo 2? It's I explained a bit earlier. We have tools like Design Studio, Qt Creator, the Qt Quick Ultralight runtime, but it's more than that. We support various tools from the embedded ecosystem that help you a bit integrate these other tools from your workflow together with Qt. So these are design tools like Figma, Photoshop, but also common embedded tool chains like IR, Green Hills. We support also AutoSAR for at runtime for automotive cases. And then we have also our QA tools, which are also enabled for this platform. We support all the different variants of the Traveo, so for graphics at least, the 4M, the 2D6M, and the 2D6M DDR that each target slightly different resolutions, but Qt works basically exactly the same way on each. We also aim to make this as easy as possible. So we have various demos, example, documentation, and we have very good partners like Witekio that are able also to help, let's say, helping you create application with Qt on the Traveo, or maybe, for example, porting an existing Qt for MPU onto an MCU. And to conclude, just to mention that we have this quick start guide to help you get started with Qt on the Traveo 2. Shows you how to use Design Studio, then Qt for MCUs, and to compile that with Green Hills to run it on the Traveo board. And I think that's more or less what Remy has done here to create a demo that he's going to show you. We follow this guide. So I think it's also give you a good now practical idea of how it looks like, I guess, or how it is to create these applications. Thank you.
Thank you so much. Remy, you ready?
Yeah, absolutely. Thank you, Johan. Thank you, Sankalp. So we have seen now the hardware part, we have seen the Qt framework part, and now we will dig into the code. It's a part two. If you missed the first webinar, we already discussed how to migrate from the Qt for MPU to the Qt for MCU world, how to convert a small, simple user interface from Qt Quick to Qt Ultralight, and also how to exchange data between the back end of your application to the front end. If you missed it, you can still go and look at it. Yeah. This time, we want to dig a little bit further and to see the performance we can achieve, and mainly on the animations side of an application. Yeah, so the challenge we tackled, we reused an already existing application developed fully by the Qt internal team. It's a medical demonstration of a 3D beating heart. It's running on desktop. We will see it in a few seconds. Everything is rendered using mesh, and everything is handled by the GPU. Our goal was to have an animation emulating this beating heart at 60 FPS using the Traveo T2G. I'm sorry about the name. I will call it the 4M from now because it's really difficult. And also with a specific display, what we need to know, it's 800 by 480. And we had only 15 days to set up everything. We can look at the starting software a little bit. Yeah, thank you, Georgie. So it's running. Here, we are not talking about all the nice little buttons and options that we have, but we are really focused on the beating heart. Yeah. Okay, so the environment. First, we had to set up everything. Here, we are mainly talking about the development tools. We will see the hardware setup just afterwards. So two IDEs, Qt Creator, and we are also using the Green Hills multi and all the environment Green Hills can offer, the software compiler, and everything is running so in the Infineon MCU. We are using CMake to handle everything on the build process, and a little bit more than that, but it's not really useful here. And also we are using Qt for MCU, obviously. And everything is running on desktop and on the final target. It's important to note because, as we know, the developers really like to have everything run on the desktop. From an efficiency standpoint, it's really the best way to go to have everything run on your desktop and also on your target. And to deploy everything, we have also another tool provided by Infineon, and we have a specific bootloader that you can find. Everything is done by Qt and Infineon, more or less. On the hardware part, we have the T2G4M, we have the display. Here is a small photo, but I'll show you it just next to me in a few minutes. We also have specific flashing tools. On the photo, you can see it's the little key in blue. And you need it to flash your software from your building environment to your target. And I also wanted to add a little bit of what we are dealing with in terms of memory, because for the animation and for the images, we will see that in a moment, it's really what matters. So we have 4 megabytes of flash, we have 2 megabytes of VRAM, 64 megabytes of NOR, and 64 megabytes of QSPI. We have not used the QSPI at all for the moment. Yeah, let's go. Okay, first, obviously we had to rethink the solution. Why? Having something in 3D on an MCU, it's not possible yet. So we had to come up with another solution. The Qt company helped us with that. They already have done it in the past. So what did we do? We have a 3D scene running on our desktop. We are exporting the scene. We are more or less doing a video of it, and we are using a third part hardware software to splice the video into images. On the right, you can see just a simple example on what we have been in the code side of things, what it translates to. We have what we call an animated sprite. It's an object that you can find in the Qt for MCU framework. You give him all the images you want to display. Here it was the really first step, so it's really simple, and it was not a great thing for the eye, let's say, but it's still a starting point. Regarding the screen and the environment we have, we decided to create images. It's 480 by 480, and it translates to around 80 kilobytes for one image on the target. To split the video into a set of images, we used several solutions, but we settled with FFmpeg. It's easy to use, and the results were great. First, we had several options to optimize a little bit the application. The first one we tried is the PNG compression. So everything is handled by Qt for MCU on this part. You just have to set up the compression in the QML project file. You have to handle several variables like the resource cache policy, set the cache at the right amount, at least the size of your largest image, and everything will be stored on RAM. On the right, you can see what it translates to in code. The results. With this setup, we could have around 10 images on the application, and everything is limited by the RAM. The main pros, it was an efficient compression method. However, obviously, as everything is stored in the RAM, everything is cached. I'll tell you a little bit about some KPIs we got on this one. I don't know, Georgie, if it's on another slide or not. Okay, I'll go with orally then. It's 18 FPS with this solution. The VRAM usage is at about 50%, so we have 1 megabyte. The CPU load was 13%. Everything is cached in the HyperRAM, so we had obviously 6 megabytes of data inside, and we have 240 kilobytes for the VRAM data cached. One other count that is not written here, the caching process is taking around 10 seconds when you are booting your application. Afterwards, you don't see anything more, but it's something to take it into account. All right. Okay, the on-the-fly compression. This one is another approach. This one is based on a tool provided by Infineon. It will compress all your images using a custom run length encoding. So the main benefits, you don't have any more CPU time required. And afterwards, you have to, there is two main things you need to do. Create the resource file and add it to your Green Hills project. And also, you will have all the images stored in the raw data section of the Flash. Once again, let's see the results. Okay. On this part, for those one, the KPIs changed a bit. We could have 24 images, so a lot more than the first step. And this time we are not limited by the RAM, but we are limited by the Flash available. Running the application running, we are at 30 FPS. The VRAM usage is exactly we are at 1.7 megabyte. We have a CPU load of 7%, so it's decreased. The data cache in the VRAM is exactly the same. However, the Flash is absolutely fully consumed. So we had around 3.5 megabytes directly stored in the raw data. So once again, the pros, it's another efficient compression method, and it's not using the RAM cache. The drawbacks we saw, we didn't have time to see if we can have this method applied to another section of the memory. So we are limited by the raw data section and the size of the flash. And there is more manual steps to create the compressed image. And you also have, as I said, you need to adapt your Green Hills project. But the results were way better. Let's see the third option we have. On this one, so there is also another type of memory present on the 4M board. We have a flash, and here we have 64 megabytes. So yeah, we will be able to store a lot more of images. So we will be able to have really better animation and better performances. We just followed a simple documentation. You will have access to all the links at the end of the presentation, but more or less what you need to understand that it's the same way you are flashing your application when you follow the first step. You just have to change some command line on a user perspective. It's not more work. We ran into just a little situation where we needed to adapt the deployment scripts. Not much work to do here, but we had to do it anyway. For the results this time, okay. So it's way better. We have way more space. So this time we could store 2 sets of 60 images. So the grand total, we have around 130 images available for the sprites. So we could have, we have actually, an animation running at 60 FPS. We are using the same amount of VRAM. The CPU load is a bit higher than with the on-the-fly compression solution, but it's not high, not that high. We are at about 10%. The data cached in the VRAM is exactly the same. We have only 500 kilobyte data stored in the flash and 64 megabytes stored in the Semper flash. The pros, obviously, we have a huge memory boost. So we can have finally what we aimed. And actually, we have even double of what we aimed because we have 2 sets of images to run with the beating heart. The main cons at the moment, we don't know if we can use some kind of compression. We have not dabbled in this part, so maybe you can use this with the other option we presented, but it's still a work in progress. I don't know how to do it right now. There is more manual steps in this, using also this approach. You have to erase the bootloader, reboot the board, flash the application, and reflash the bootloader. So it's a bit more tedious, but yeah, it's a cons. And the last one, we also saw that the flash time is way higher. For us, we had around 10 minutes to flash the whole 64 megabytes. Right now, I will share my screen because obviously I said to you that we have developed something, but it might be better if I show it to you. All right. Please be gentle. Okay, let's just starting up. So yeah, it's the latest solution with the 2 sets of 60 images. We also added a side panel for just because we think it's fun. And when there is a timer changing the rate of the heart. The first 60 images are for a plain beating heart, let's say, and the 60 others are for the translucent one. I'm sorry about the quality, but filming a screen is always a bit tricky. And everything is running at 60 FPS. If you see sometimes some minor glitches, it might be us, or it might be the streaming. I'll let you decide. I think we are okay with that. I'll switch back to my other camera. Or maybe not. Maybe it's better to see this face. Okay, let's go with the conclusion. What are our conclusions? What was the most difficult or the most unsettling for an MPU specialist? For us, the complete development and deployment environment is a bit more complex. We saw all the tools used, all the different devices. We use the Green Hills environment. We are using the Qt environment. It's not difficult, but it's complex. There is many parts of the system. However, the integration and the job done by Infineon and Qt it really helped us. All the documentation present, the quick start guide and everything else, it really helped us. We are end users. We are reading documentation, we love that, and we are applying it, and it works. So yeah, really good job on that. Afterward, the other takes is that we used really specialized engineer in Qt, but he had no prior knowledge in MCUs. Just feeding and working was with the resources that we had, and in a little time, everything was really smooth. The transition, the competency improvement, ramp up is really, really easier than what we expected. One note on that side, we mainly worked on the application, the user interface, not that much on the back end. So maybe this opinion can change, but we have highly specialized MCU developers too. So maybe a group of 2 developers is the right team when you need to start a project like that. Someone with really expert knowledge on the MCU world, on the back end, on the C++, and one specialized on the Qt framework and Qt application building. As you have seen, I think it's really one thing that stands out when you are working with a Linux and you are switching to an MCU, the boot time. It's absolutely incredible. I think just for you, and because the camera is still here, we can do another test. And yeah, for me, it's baffling. The performance is it's great. We are used to work with MPUs. We know we can do with really high-end MPUs, we can go further, but here, I think on the MCU world, we are really reaching new heights, so the performance were really, really great. And another thing, we have seen it through this presentation. The main thing is about the memory and the space taken by the images. We wanted to push it. You don't have to have that big of a heart on your screen. We just wanted to see what we can do with the system. You can really think differently your application, and it will handle way more resources than what we have been using. And so, yeah, the last slide is only the link. So for my part, it's all.
Look at that. That was insane. We had multi-camera action going on. We had a live demo. There was hardware. Remy couldn't get his face back. It was brilliant. Thank you so much, everyone. And thank you so much to all of our speakers and everyone who's joined us. Do we have any questions? We're at the top of the hour, but if anyone has any questions, please speak now or forever hold your peace. If you do think of a question that you can, that you don't have time right now, feel free to drop us a message. Each and every one of you should have received an email from myself or from Witekio, and I will personally make sure that it gets passed on. One quick question, I will put it up onto screen for everybody. I think Remy and Johan, this is for you. Jordan from Colombia has said, thank you so much. I'm a beginner in Qt and MCUs. I was wondering if I can use Python instead of C++.
Take that question. Yeah, thanks, Jordan, for the question. That's a good one. You're not the first one to ask. So in Qt in general, we do have support for Python. So it is possible to develop entire application using Python. However, today this support of this language on MCU specifically is not available. So this is something we might consider for the future. I know some people at Qt have already looked into this a bit. But for now, at least, if you would want to get started today with Qt for MCU on Traveo, then you'd need to use QML and C++ and C as well. Yeah.
Amazing. And we have another one actually from John, who is asking, Qt-related question, is there a simple approach on how to install or create a Qt-based cross-compilation toolchain to create Qt applications for Raspberry Pi on Ubuntu? That is...
Yeah, I don't know if Remy or me, maybe I can try to answer this one. I have to say I'm not entirely sure. So maybe slightly unrelated to maybe the webinar topic. But let me see. At least I do know that with our Qt for device creation, another part of our offering, maybe more for MPU, then we do have these ready-to-use tool chains to create basically Qt application on Raspberry Pi and available for Ubuntu, I believe. So I hope that answered the question. But at least, so we call this boot to Qt. If you've not heard of it, at least that's basically a ready-to-use tool chain and a software stack for Raspberry Pi and available on Ubuntu. So if you look it up, maybe boot to Qt, you might help with this.
Amazing. Johan, if you send me a link, I will make sure to send that out with the slides as well. So along with all of Remy's resources, which he lovingly put in here for everybody, this will all be sent to you so you can access everything and see it. Another question for Qt. Can Qt for MCU support touch panels?
Can take that one as well, maybe. Yes, of course. So touch support is fully available in Qt for MCUs. It works in the same way as on normal Qt or big Qt, let's call it. Yep. So of course, there's a bit of integration if you're going to use a non-reference touch panel. So we have reference integration with all sorts of touch panels. If it's not supported by us, it's possible to integrate others. So that's the only bit of work that can need to be done, but otherwise then it's completely piped to the rest of Qt and that's supported.
Amazing. And a question for Infineon. Johan, you can rest. Does it exist in your portfolio that some chips can realize following chain input micro? This looks like quite a technical question. So if you need to answer it offline, Sankalp, I can send you the question and the address for you to answer it. Or if you can answer it now, that's great.
Oh. Yes, actually, it's a bit of a different question for me because it's again not related to the Traveo topics or the webinar which we are focusing right now. But I believe in the bigger picture, Infineon offers so many microcontrollers and the sensors, so this should be possible. But I would have to look it deeper. So maybe it's better we answer it offline.
Yep, absolutely. So I will send it to you so you can answer John offline. That is it for questions right now. We've run over anyway, but thank you so much to absolutely everyone who did. And as I said, if you have any others, please do send them. And what we will do is we will get them answered. All the slides, the recording, the resources will be sent to you in the next 24 hours. All I have to do again is thank you for being here and thank my lovely speakers for talking and sharing your knowledge. Thank you so much. Thank you, guys. Have a great day, everyone, and we will see you on the next one.
Thank you, everyone.
Thank you so much.
Thank you.
Bye.
Bye.
Bye, guys. Thank you. Bye-bye.